Well, hello everybody. Thank you very much for coming to this, the latest Christian Perspectives in Science seminar. Our speaker today, Richard Colling, graduated from Olivet Nazarene University with a double major in chemistry and zoology. He earned his PhD in microbiology and immunology from the University of Kansas, studying infectious diseases and their relation to autoimmune diseases. He did postdoctoral research at Baylor College of Medicine in Houston, Texas, and he has done consulting work with companies such as Bayer Laboratories, Pioneer Hybrids, and Rohn Polink Rohr Pharmaceuticals. He's now back at Olivet as a professor. Dr. Colling teaches in the biology department. He has served as department chair, and he continues to do research. And he has also written a book called Random Designer, and there's a lot of extra copies of that book in boxes by both doors and up here on the front desk, and Professor Colling will make an announcement about that in just a minute. He's here today to share with us some of the ideas that he has developed about evolution and Christian faith that he's developed over time teaching students and thinking about his work. So let's welcome Professor Colling. And then in a pocket anywhere.
Well, thank you very much, Lauren. Am I coming through okay? My students tell me I tend to not speak loud enough. I'm a rather soft-spoken person.
Yeah, that doesn't amplify, just records.
Is that better?
It doesn't amplify,
just
okay. Records. So your voice will have to carry into the whole room.
Well, so I'm going to have to project then. I want to thank Lauren for inviting me to come up to be with you folks today. I've been looking forward to this ever since he first contacted me, and Doug Kinchy as well from Grand Valley State. Thank you. Before I get started with the thoughts I'd like to share with you, let me just pick up on what Lauren said. I've brought lots of copies of the book, so if you've not received a copy yet, you're welcome to have a free copy. And if after listening to me talk for 45 minutes or so, you decide you'd like to hear 2 hours more, I have a limited number, maybe 12 or 15 DVDs of a talk that I gave at our school some time back, both to students and faculty. And so it's not very redundant at all to what I say today. It really goes into much more detail in terms of what I'm trying to communicate. I had 2 hours there. So anyway, so with that, let's go ahead and begin. In 1905, in the summer, patent clerk who had recently turned physicist radically changed our view of the world with just one mathematics equation. You all know what it was. E equals mc squared. With this simple but ultimately profound equation, Albert Einstein defined the basic elements of relativity, showing that matter and energy were really just different forms of the same thing that could be interconverted. The ramifications of this revolutionary concept were enormous, ultimately sowing the seeds for the nuclear age that occurred in the 1930s and 40s. Einstein summed up his work on quantum theory with the legendary statement, "Alles ist relativ." All is relative. Thus, the unlikely candidate of contingency turned out to actually be a foundational unifying principle of physics. Today I'd like to share with you another maxim, one that is allowing me to perceive the world in new and stimulating ways. Alles ist Zufallscharakter. All is randomness. We have one German-speaking person in the room. No doubt at a religious institution like you have here and at the school where I come from, such a statement is bound to raise a few eyebrows from time to time. After all, words like relativity and randomness sometimes do not seem theologically congruent with our concepts of a God who sets universal standards that are unchanging, and a God who also displays unrivaled creativeness. But before you rise up and cry heresy, I would beg your indulgence for a few moments. You see, there is much more to this concept of randomness. Alles ist Zufallscharakter. Indeed, I believe that it has God's fingerprints all over it. So that will be the primary focus of my talk today, attempting to talk about this word randomness and how we perceive it and how we relate it, particularly in biology, since that's my field. But I think in order for us to perhaps grasp a bit of a view of what I'm trying to communicate, it's important to see a bigger picture. I remember some years ago when my second son was about 10 years old. It was a Saturday, and I was up in my study, and we have a 2-story house basement, and he was downstairs in his room, and I heard him yell, "Dad, Dad, come on down, come quick." So, you know, I came as quick as dads come when you have 4 sons all calling for you. But I got up at my desk, went down to see what Landon was all excited about. When I got down there, here was Landon, this little 10-year-old boy, standing against the wall looking at one of these big posters, you know, those stereo cryptograms that were all the craze here a few years ago. Those mosaic of colored dots that are supposed to have other images present in them for those who are cross-eyed enough to see them. Well, he said, "Dad, look, there's a sailboat and a shark and 3 dolphins. They're swimming in the water. Can you see them?" I said, "Okay, I'll try." So I came up to the wall. He said, "You need to stand about this far away." So I got settled, and I looked at it, and I looked at it, and I looked at it, and I tried to go cross-eyed and looked at it some more, and I couldn't see it. I tried a little bit longer, and I said, "Landon, can't see it." And I could just see the disappointment in his eyes. You know, 10-year-old boys, he wanted to share with his father what he had seen. So I believed in what he was saying. I believed he was probably right. They were there. I just couldn't see them. So I resolved in my mind that I would keep on looking. So over the next couple of weeks, every time I was down in his room, I would just sort of saunter over to the wall and start gazing at this poster. You know, it would look kind of funny if you didn't know what I was trying to do. But so I did that, and once again, I mean, I'd look, and just no success. Usually I tried to sneak down when no one else was at home so that none of the rest of the family would know how perceptually challenged I was. But finally, one day, I went down, and he had called me down again, and I just stepped in front of it, and I started looking at it. And for reasons I have no idea why, this time, when I looked at it, all of a sudden, part of it seemed to sort of shift forward. At the same time, another part shifted backwards. And there it was. All of it. The dolphins, the shark, the sailboat, exactly as Landon had described it there. Hidden within the randomness of those mosaic dots, but only visible to the person who had the patience and the diligence or the luck to be able to stand in front of it long enough and keep searching. So that's one of the things that I'd like to convey to you, that this concept of randomness is something that's really quite significantly, I think, misunderstood. In biology, I'm a biologist, so in biology, this idea that things appear random or that there's multiple variables involved in deciphering things comes into play in biology a lot. So I call this higher order thinking. And it's really just understanding that in order to understand some larger perspectives, we need to pull dots from different disciplines. We're really in a whole world of hurt if we are narrow chemists only. I'm not attacking chemists. I got a degree in chemistry too. Okay, but the same thing applies to biology or physics or art. So what you see here is that I've identified lots of different dots here. And I think all of these dots, in one way or another, I will address today. And you'll see that, in some sense, all of these connect to what I'm trying to communicate to you. Communication, science, language, culture, mathematics, I love the math, music, religion, history, art, and information science. And so when we talk about biology, biology is not a simple equation. Biology really is lots of different variables coming into play to give us this remarkable thing that we call life. And it is indeed remarkable for those of us who study that for a living. And so our challenge then is really more like this. It's not, in terms of trying to teach biology, say, here's a frog and now here are the parts of the frog. That's not biology. Our challenge as educators in biology is to communicate a few chemical elements on this periodic table that you all saw in high school and others, those that are not scientists, sort of discarded as irrelevant to life. Carbon, nitrogen, phosphorus, oxygen, hydrogen, a few chemical elements here